Okay, so have you ever thought about how some of the biggest secrets of the universe might be right there in front of us?
Hiding in plain sight.
Yeah,
Exactly.
exactly, like hidden in these giant numbers that are almost impossible to even imagine.
I like that, yeah.
So that's what we're going to be diving into today. The world of what are called large number coincidences in physics.
Right, and how those might connect to something called the Anthropic Principle.
Okay, so that sounds pretty intense.
It is pretty wild stuff. It's basically looking at these strange relationships between numbers that come up when we describe the universe.
And we're talking about really, really big numbers here, right?
Yeah, huge numbers. And that's actually what makes it so fascinating for physicists. We're talking about numbers that are so big, it's hard to even grasp their scale.
So for this deep dive, we're going to be looking at a paper by Brandon Carter.
Yeah, large number rows, coincidences, and the anthropic cosmological principle.
And what we're trying to figure out is whether these strange numerical relationships are just random accidents.
Or if they might be telling us something really deep about the universe and, how we fit into it.
Right. So where do we even start with something like this?
Well, one of the first people to really notice these weird number patterns was Paul Dirac.
Oh, yeah, the famous physicist.
Exactly. Back in the 1930s, he came up with something called the large number hypothesis, or LNH.
And what is that exactly?
Well, he noticed that several huge numbers that describe different aspects of the universe all seem to be about the same size.
Okay, so give me an example. What kind of numbers are we talking about here?
So one classic example is the ratio of the electric force to the gravitational force between a proton and an electron.
So, how much stronger is the force that holds atoms together compared to the force of gravity?
Exactly. And that ratio turns out to be a number around 10 to the power of 40, which is a 1 followed by 40 zeros.
Okay, that is a really big number.
It is. And then Dirac also looked at the age of the universe, but he expressed it in a special unit.
Oh, so not just years.
Right. He used what's called the atomic unit of time. It's basically the time it takes for an electron to go all the way around a proton in an atom.
So a tiny fraction of a second.
Super tiny. And what he found is that the age of the universe in these units is also a number close to 10 to the power of 40.
Hold on, so you're telling me that the strength of forces inside an atom and the age of the entire universe both come out to roughly the same massive number?
Yeah, and that seemed way too coincidental to Dirac. He thought there had to be some kind of connection there.
So it's not just a random fluke.
Right. He thought these large numbers might be linked by some kind of fundamental law of physics.
The law that we haven't discovered yet.
Right, and that's where things get really interesting. Because if these numbers are linked, and one of them is changing over time...
Like the age of the universe is constantly increasing.
Right, then Dirac's hypothesis suggests that some of the fundamental constants of physics might not actually be constant.
You mean things like the speed of light or the gravitational constant?
Yeah, those are typically assumed to be fixed values. But Dirac proposed that maybe they're slowly changing as the universe evolves.
Whoa. So our whole understanding of physics could be wrong.
Well, not necessarily wrong, but it could be incomplete. Dirac's hypothesis definitely shook things up because it suggested that physics might be more dynamic than we thought.
I can imagine.
Mm.
So has Dirac's idea been proven?
Well, not quite. It's been really hard to test because the predicted changes in those constants would be incredibly small.
So we haven't been able to measure it.
Not yet. And as measurement techniques have gotten better, they've actually put pretty tight limits on how much those constants could be changing.
So Dirac's idea is looking less likely.
It's definitely been challenged. But that's what makes science so exciting, right? We keep testing and refining our theories. And that brings us back to Brandon Carter's paper.
Right, because he took a different approach to these large number coincidences.
Yeah, Carter agreed that these numerical relationships are really weird, but he offered a different kind of explanation.
So before we get into that, what other large number coincidences are we talking about, besides the ones Dirac noticed?
Well, one that Carter talks about has to do with the estimated number of particles in the universe.
Like how many protons, neutrons, and electrons are out there?
Right. The total number of those particles is estimated to be around 10 to the power of 80.
Wow. Okay, another ridiculously huge number.
And that's roughly the square of 10 to the power of 40. So if Dirac's number is like n, then the number of particles is basically n squared.
So that seems like more than just a coincidence, right?
It does. And Carter also discusses potential coincidences with the cosmological constant.
Okay, remind me what that is again.
It's basically a term in Einstein's equations that represents a kind of energy associated with empty space.
Oh, right, I've heard of that. It's supposed to be driving the accelerated expansion of the universe.
Yeah, and it's incredibly small, but not zero. And trying to calculate its value from first principles leads to these huge discrepancies with what we actually observe.
So another large number of problems.
Exactly. And all of these coincidences together really make you wonder if there's something deeper going on.
Like the universe is trying to tell us something.
Yeah, and that's where Carter brings in this really powerful idea, the anthropic principle.
Okay, so what is the anthropic principle?
Well, it's a way of thinking about the properties of the universe based on the fact that we as observers exist.
So our existence kind of puts limits on what the universe can be like.
Right. The basic idea is that we wouldn't be here to observe a universe that didn't have the right conditions for life to emerge.
Okay, I can kind of see where this is going.
Mm-hmm.
So how does this apply to the large number coincidences?
Well, instead of looking for a fundamental law that forces these large numbers to be related, the anthropic principle says maybe they're just necessary for us to be here.
Like a prerequisite for our existence.
Exactly. Carter argues that we shouldn't be surprised to find these coincidences because if they weren't there, we wouldn't be around to be surprised.
It's like the universe had to be a certain way for us to even ask these questions.
Yeah, and he digs into different types of anthropic reasoning. But one that's particularly relevant here is the weak anthropic principle, or WP.
Weak anthropic principle. Okay, what is that?
It basically says that our observations of the universe are inherently biased by our own existence.
Biased how?
Well, we can only observe a universe that allows for observers like us to exist. We can't observe a universe that's incompatible with life.
Okay, so give me an example of how this applies to the large number coincidences.
Sure, let's take the coincidence between the typical lifespan of stars like our sun and the age of the universe.
Okay, and why is that a coincidence?
Because there's no obvious reason why those two timescales should be similar. From a pure physics perspective, it seems like a pretty big coincidence.
One is about nuclear fusion inside stars, and the other is about the expansion of the entire universe.
Right, but the anthropic principle says, hey, wait a minute. We can only exist if there are stars that live long enough for life to evolve.
And if the universe isn't old enough, those stars wouldn't have had time to form in the first place.
Right, so the fact that those two timescales are similar is a necessary condition for our existence.
Okay, I'm starting to see how this works. So from our point of view, it's not really a coincidence. It just had to be that way for us to be here.
Exactly. Carter is saying that our existence acts as a kind of filter on what we observe.
We only see universes that are compatible with us being here.
Right. So the anthropic principle provides a different way of understanding these seemingly improbable coincidences.
A really interesting perspective. It makes you wonder if maybe we're overthinking things sometimes, looking for complex laws when the answer might be simpler.
Yeah, it's a good reminder that we always have to consider our own role as observers in the universe.
But is the anthropic principle a complete explanation? I mean, does it have any weaknesses?
That's a great question, and there's definitely some debate about that. One criticism is that it can feel a bit like giving up, like saying we can't find a deeper physical explanation, so we'll just blame it on our own existence.
So it's not very satisfying to some scientists.
Right. And some argue that it doesn't really make testable predictions. Like, it explains why we see what we see, but it doesn't tell us what else might be out there.
So it's more of a way of interpreting what we already know than a way of discovering new things.
Yeah, that's a fair point. But it can still be a valuable tool for understanding the universe and our place in it.
So let's try to wrap this up. We started with Dirac's large number hypothesis, which proposed that some of the fundamental constants of physics might be changing over time.
And that was his way of explaining these large number coincidences.
Right. Then we looked at Carter's work, which introduced the anthropic principle as an alternative explanation.
Right, and Carter argued that these coincidences might not be so surprising if they're just necessary conditions for our existence.
So Dirac was looking for a fundamental law of physics, while Carter was focusing on the role of the observer.
Exactly, two very different ways of approaching the same problem.
And neither one has been definitively proven or disproven yet.
That's the beauty of science. There's always more to explore.
So for you listening out there, we've just taken a deep dive into these incredible large number coincidences and how they've led to some really profound questions about the nature of the universe.
Are they signs of deeper laws or simply a reflection of our own unique perspective as observers?
It's something to think about.
Yeah.
And it really makes you appreciate just how vast and mysterious the universe is.
Absolutely. It's a constant reminder that there's always more to learn and discover.
Thanks for joining us.
Yeah.
And who knows, maybe one day we'll have the answers to these big questions.
Until then, we keep searching.
And keep wondering.
Exactly.
Okay, that's it for this deep dive. We'll see you next time.